All right, well, let's go ahead and take a look at our Module 13 review. One thing that I know that is an issue in our math classes is that we usually do problems in stages, and so all of the problems have the same style of solution. And then when a test hits and the problems are mixed together, we have a trouble with that. And so that's one of the things that we decided to do within this particular review is have the different styles mixed together. So we have to have a little dexterity to have one strategy on one problem and another strategy on another one. So anyway, let's go ahead and kick this off and take a look. So we'll notice that in our first problem, this is not a special right triangle, because if it was a special right triangle, either these two values would be identical, 8 and 8, or 45, 45, 90 maybe, or this one would be exactly this guy times root 3, but that's not true. This doesn't say 8 root 3, it says 27, so it's not special. So we're going to have to use regular SOHCAHTOA trig. So remember, for regular trigonometry, we use SO, CA, and TOA. And when I looked at this, I noticed that from the x, I have this side, which is far away, which is we've called opposite. The hypotenuse was not marked, so it's not either one of these, but they did give me the adjacent right here. So this is definitely going to be a tangent. But again, unfortunately, they didn't tell me the value of x. I don't know the angle, but I know that the tangent is the ratio of the length of the opposite side, 27, to the adjacent side, 8. Well, this is one of those problems where I'm looking for the angle. So instead of hitting the tangent, I have to hit second tangent. And I'm going to ask it, hey, calculator, what is it that when the tangent is 27/8 and the calculator says it's 73.5 degrees? And we're done with that problem. Awesome. Now let's move over to here. Now, again, I could potentially use regular trigonometry because I'm looking for some sides and angles, but this is a special case because remember, if you have an equilateral triangle, all of these are 18. As soon as you drop this altitude in, that makes this side right here a 9. And therefore, if that side is 9, that makes this z right here 9 times root 3. So I've got that. And that tells me that this was all 60 degrees. So I know that side W, let's see, was 9. That side is 9 roots of 3. And therefore, my angle X right here was 60, because if it's equilateral, all of these angles would be 60. And of course, when we cut that one in half, we got 30 degrees, because this is right here is a 30, 60, 90 triangle. Now, again, as you look at this problem, again, just using that idea, a little bit of pivot. Again, this is another 30, 90, so therefore 60. So we've got another 30, 60, 90 triangle. So we want to remember that in a 30, 60, 90, whatever you do from here, I'd have to double it to get this one. So times 2, or to go from here to here, I'd have to multiply by root 3, or in other words, to go backwards, I'd divide by root 3. So if I took 9 roots of 3 and I divide it by root 3, those would just cancel out, and I just get that x is 9. And since this side doubled makes the hypotenuse, that makes y 18. Awesome. Now, as we go through these, we're doing pretty fast. And now we look at this problem, we're looking for x. Well, they didn't give me the angle, they didn't give me some stuff. But remember, this is a right triangle, which means the Pythagorean theorem is always something we can use. So let's see. If I said a squared plus b squared is c squared, the big thing you want to remember on that is that the c is always going to be your hypotenuse, okay? And so since that is our hypotenuse, we could start doing the Pythagorean theorem. 14 times 14 is 196. I think 16 times 16 is 256, but I'm going to double check that. Yeah, it is. So we'll subtract 196 from both sides, and I get 256 minus 196 is 60. And so x, I'd have to take the square root of both sides. Now, that's the first time I'm going to have to do something a little bit fancy, is that I want to think about that 60 is 2 times 30, but 30 is 2 times 15. And 15 is 3 times 5. So we can play Go Fish. 60 is 2 times 2 times 3 times 5. And I have a pair of 2's, but I have a leftover 3 and a 5 inside. So that would be 2 roots of 15. Now, again, for the test, I would really, really encourage you to take 2 square roots of 15 and see what that is. That gave me the decimal 7.74. And then try the square root of 60 and see if it also gives me 7.74. And it did. So I know that my simplification was correct. Now, these last two clearly are also not special right triangles either, because they're not 30-60-90s or 45-45-90s. So we're going to use regular old-fashioned trigonometry. Now, this one is going to ask me to use it twice. And so if I took the tangent of 64, that would be the ratio of the opposite, the faraway one, which is y, divided by the close one, the adjacent one, which is 15. So if I could multiply both sides by 15, that would allow this y to be all by itself. So I just need to take my calculator and say 15 times the tangent of 64. And I got that my answer is 30.75. That's going to be y. Now I've got options for getting x. If I want to, since I know both of these sides, I could use the Pythagorean theorem, or if I'd prefer, I could go ahead and use trig. I personally like trig better. So I would say that the cosine of 64 degrees would be the adjacent one. Remember, cosine is adjacent over hypotenuse. So the adjacent is 15 and the hypotenuse is x. Now this time, if I cross multiply, sorry, I wrote that badly, but if I cross multiply, or in other words, multiply both sides by x, x times the cosine is 15. So I just need to take 15, and since x is being multiplied by the cosine, I'm going to divide by that cosine. And when I did that, I got 34.2. Okay, 34.2. Now, just for giggles, I want to double check something and make sure that I have not made a mistake. I want to take 15 squared plus 30.75 squared. And then I'm going to take the square root of that because I'm doing the Pythagorean theorem real fast and making sure that I got the answers that I was hoping for. And that tells me that those numbers work together. And so I most likely did all right. And my last one, again, not going to use the other stuff. This would be the opposite. And so when looking at the stuff, I don't have the opposite. So the two trig ratios that have opposites are out. It has to be a cosine. So again, I could say that the cosine of 33 degrees would be the adjacent, which is here, divided by the hypotenuse. Now, we actually spun that triangle upside down to see if we would trick anybody. So multiply both sides by 19, because that would make that cancel out. And so if I could take 19 and multiply it by the cosine of 33, I'd be done. 19 cosines of 33. And we're looking at 15.9 would be our answer. So that's the end of the first page. Hopefully that was helpful, and I will see you later and back in class.